This video is to review lesson 2-4 quadratic word problems. So I'm going to have our screen split with Desmos, and we're going to title this graph lesson 2-4 word problems. And you guys should be prepared to have this graph saved and submitted. So I'm going to start by reviewing the quadratic keywords. There is an additional video for this review, so I'm not going to spend a great deal of time on it, but we do need to understand these keywords. So when I'm looking at my vertex, we have our x value is always when. It's always going to represent time. My y value is always going to represent height. My y-intercept is always my initial height. So that's where we're starting out. And we can be asked questions like, how high is the object after blank seconds? That means I would plug in the given seconds to the equation. So we're going to use function notation. So let's say if it wanted to know 3, I would find f of 3 and replace 3 in my equation and solve. So when we're given a word problem, our first step is to identify what the question is asking, whether it be your y-intercept or the x or y value of your vertex, or possibly one of the positive or negative zeros. So we're never going to deal with negative time. So we're not going to have a negative 0, but this question for our positive 0 can be phrased as, when does the object hit the ground? Or how long does the object stay in the air? So either way, we need to understand that when our object hits the ground, this is when y equals 0. And our y-intercept is when x equals 0. So before the time starts, before it is launched. Other information we need to be aware of in our equation. So we're going to be given one of these two forms when we're dealing with projectile motion. So this is when an object is being launched or thrown, or an object is falling, any of those situations. So this coefficient of t, because we're usually going to have h and t for height and time, the coefficient of t is going to be my velocity or speed. So that's telling us how fast is the object going. So for example 1, a dead missile is fired straight into the air from a military installation. The missile's height is given by the formula h of t equals negative 16t squared plus 400 t plus 100. Another thing we need to notice is that I'm either going to be given negative 16, so that's when we're measuring in feet, or I'll be given negative 4.9, that's when we'll be measuring in meters. Any other time, sometimes there'll be word problems where something is being launched on the surface of Jupiter or another planet, something like that, because this number is acceleration due to gravity. So we get into acceleration, that's having more to do with physics and a little outside of what we're going to deal with in Math 2. So when I'm being asked how high is the missile off the ground when it is fired. That's going to be my y-intercept, which is always the c value in standard form. So for this problem, that's going to be 100 feet. And it's really important that we always remember to include our units. So when we're asked about initial velocity, that's going to be the coefficient of t. So in this case, that's 400. And velocity is going to be feet per second. How high is the missile after 4.5 seconds? So that's a question where I need to use function notation. So if I have f of 4.5, and this is something we can put in the calculator, but if I were to plug this in, it would look like this: negative 16 times 4.5 quantity squared plus 400 times 4.5 plus 100. So that is going to end up equaling 1,576 feet. At what time will the missile reach its maximum height? So at what time, t is going to equal 12.5 seconds. So this is going to be the x value of our vertex. And we're going to show all of this in Desmos. I just want us to write everything down first. What is the maximum height? So height h is going to be 2,600. What time will the missile land on the ground? So it's going to land on the ground at t equals 25.25 seconds. When will the missile be 2,500 feet above the ground? So the thing that's special about this, it has a star here. What's special is I'm going to have two answers, because if I think about a parabola where we are going to be launching from a specific height and then falling, let's say that this is where we have 2,500 feet. It's going to have two intersections. So understand that feet is y. So if I have the line y equals 2,500, that's going to cross my graph at x equals 10 seconds and x equals 15 seconds. So now let's type this into Desmos and look at these features. So we're going to have y. So we're usually going to use y in Desmos instead of the function notation, because Desmos doesn't really like function notation as much. It's much more friendly when we use y. So y is going to equal negative 16. Use x as well. Squared plus 400 x plus 100. So this zoom view looks pretty weird. So we're going to need to collapse this equation part and zoom out until we see the top of our graph. And then we'll need to zoom in. This is going to take some careful zooming to figure out. But when we find our vertex, we see that the x value is 12.5. The y value is 2,600. That's part C, part D, and E. We're trying to find part C, how high is it after 4.5 seconds? I need to know when x equals 4.5. So now I can go back home x equals 4.5, I want to know where this is going to intersect my graph. So we need to zoom out again so I can see where this line is going to intersect with my parabola. And we can see here that trying to do this graphically is really giving us a hard time. So we don't always need to rely on the graph. Using Desmos isn't always a shortcut. Sometimes it is easier to do the computation. So if I use what I know about function notation, I can figure out this answer. So I can plug the math part in. So if I have negative 16 times 4.5 squared plus 400 times 4.5 plus 100, and we get our answer. So it was going to be a lot trickier to try and find the intersection on the graph than it was for us to just plug in x and solve for y. We're trying to figure out what time does it land on the ground. That's when y is going to equal 0. So that one's a little bit easier to find. We can just slide along our x-axis and click on the graph, and it will give us our value here. So we rounded 2 places behind the decimal. And for G, this one might be a little bit easier for us to find on the graph, because if I know that y is going to be equaling 2,500, I can use that to help me adjust my window. So I know that I'm going to need some positive x values, and we can just set this to a range that we think would be acceptable. But if I know that my y value is going to be 2,500, I can set my window to one that is going to show me that value. And I set that at the top. So when I have that line, I see that it crosses my parabola at 10 and 15.